Okay, so to find an inverse of a 3 by 3, right, so there's a few processes to do first of all. Let's call this matrix A. So the first job is to find the determinant of A. So to get the determinant of A, it'll be 1, block that out, that's 5, 1, minus 1, 4. Take away the middle term, which is minus 2, so that goes to plus 2. Take the T-shape, 1, 2, 1, 4. Plus third one, take that row out, take that column, 1, 5, 2, minus 1. There'll be one lot of, that's 20, minus 1, plus 1, plus 2 times 4, take away 2, plus 1 times minus 1, minus 10. So that's 21, 4 take away 2 is 2, 2 2s are 4, minus 11. It's 21, that's 10 and 4, so that's equal to 14. So the determinant is 14. Now then, to find the inverse, the first job is to find what we call the matrix of cofactors. And that's what, in effect, that's these here, what I've worked out in order to calculate the determinant. These are what we call the cofactors. Okay, so we're going to have to do this now. So to put the entry in there, block out that row, block out that column, and then it's 20 minus 1, which is 21. This one, T-shape, 1, 2, 1, 4. So it's 1 times 4, take away 2 times 1, which is 2. And finally, row, column, 1 times minus 1, minus 10 is minus 11. So the first row, in fact, I've already done those cofactors to calculate the determinant. Okay, so the values in the brackets there, so what's being fitted in that row. Now I need to do the same for the second row. So this one here takes out those entries and those entries, so I'm left with those 4. So it's minus 2 times 4, that's minus 8. Take away minus 1 times 1, so that's minus 8. Add 1 is minus 7. The middle entry blocks that row out, that column out, so I got the 4 corners. So that's 4, take away 2 is 2. And the final entry in the second row takes that row out, takes that column out, so it's minus 1, take away minus 4. So that's minus 1 plus 4 is 3. And for the third row, takes that row out, takes that column, so it's minus 2, minus 5, minus 7. Bottom one goes out, so that's 1, minus 1, 0. And finally this entry here, row, column, 5, take away minus 2, so that's 5 plus 2, which is 7. Just the matrix of cofactors. Now the matrix of minors, what we do, we use the same entries, but what we do, we impose, for science purposes, I put that onto those values. The matrix of minors will be in the top row, then it'll still be 21. The middle one changes to a minus, it's 11. In the second row, these two entries change signs, that goes to 7 to minus 3. In the bottom row, these stay the same, the two end ones stay the same, so it's minus 7. The entry go to negative plus 0, so it stays the same, that's 7. So that's the matrix of minors. And then we define what we call the adjugate matrix. Some people call it a joint or adjugate, right? So the adjugate matrix. Now what I do, I transpose this matrix. Now when you transpose a matrix, what happens is your rows become columns. So this row, 21 minus 2 minus 11, gets written as a column. This row gets written as the second column, and the third row becomes the third column. And just one more step to get the inverse then is 1 over the determinant of A times Rj. So the inverse of this matrix is 1 over 14, and then it's these entries. And there's the inverse. I can do a check, see if I'm right or not. So I'll use my check. I take the inverse. I mean, if this fraction outside was such that I could divide it into all the entries inside, then I would do that. But these are not cancelling with the 14, so I leave them as they are. So if I take the inverse and multiply by the matrix I started off with, okay, so leave the 1 over 14 out. Let's multiply out across and down. So that's 21 and 14. Sorry, 21 and 7 is 28. Take away 14, that's 14. Second one, that's minus 42 plus 35 plus 7, that's 0. End one, 21 and 7, 28 minus 28 is 0. Cross and down, minus 2 plus 2, nothing, so that's nothing. 4, 14, nothing. And this entry across down, minus 2 plus 2, nothing, 0. Minus 11, minus 3, that's minus 14, plus 14 is 0. 22 minus 15 minus 7, 0. Minus 11 minus 3, that's minus 14, and 28 is 14. And divide all these entries by the 14, I get 1, 0, 0, 0, 1, 0, 0, 0, 1, which is the 3 by 3 identity matrix. So I know what I found is correct.